but I'm going to show you how you decide if you have to use the cosine rule. Okay, so far the tools that we have for trigonometry, we have things around there being a right angle triangle, which we have SOHCAHTOA. We have the area of a triangle, which is a half AB sine C, and we have the sine rule. Those are the tools we have so far. So this is just another tool that we can use to work out missing sides or angles in a triangle. So what we're going to do today is we're going to look at what the sine rule is, or sorry, the cosine rule is. We're going to look at how do you decide when to use it and when not to use it, and then how to use it. So cosine rule. So the cosine rule is much nastier looking than the sine rule, and it's in your tables book, but it does look a bit nastier. And what it is a squared is equal to b squared plus c squared minus 2bc cos a. Okay, you can see that it's that bit nastier. A squared is equal to b squared plus c squared minus 2bc cos a. And if you remember, a, b, and c are all sides, and a, b, and c in capital letters are all angles. So you can see that most of this cosine rule is made up of sides with just one angle thrown in at the end. And that'll become quite useful to recognize as we go along. So this is the rule, and what we're going to do is learn how to use this rule and when we would use this rule. So remember, with SOHCAHTOA and right angle triangles, we have hypotenuse, adjacent, and opposite. But with non-right angle triangles, so this is for use with non-rats, non-right angle triangles. Okay, so we have to label it as a non-right angle triangle. So what we will always do is the angle that we're given, we'll call that A, and the side opposite it, as we know, is side A. Okay, so the letters always go with each other. A's go with A's, B's go with B's. It doesn't really matter what we call the others, whether this is B or this is B. Well, I'll call this one B for now, which means that this angle here over here would be B, and then this must be C. Okay, and that would be angle C. So what do we have so far? The information we have is that we have angle A is 102, we have B is 11, and C is 9, and it looks like we're being asked to find A, which is a side. Okay, so what steps will we go through? The first step we'll go through is it a rat? Because if it's a rat, if it's a right angle triangle, then we'll go to SOHCAHTOA. It's not a rat, so we're going to proceed. Okay. Second rule, remember we said, can we use the sine rule? Because the sine rule is actually that little bit easier to use than the cosine rule. So if we could use the sine rule, it would be easier. Can we use the sine rule? To use the sine rule, remember, we talked about having 3 things out of 4. So let's set up our sine rule. A over sine A is equal to B over sine B is equal to C over sine C. Let's fill in what we have. A is, we don't know. The angle opposite is 102. So we have sine 102, that's fine. B we have is 11, but we don't have B, the angle, and we have C, which is 9, but we don't have angle C. You notice the difference here is that even across all 3 of the ratios or the fractions, we only have 3 things. We have an angle and 2 sides. We do not have 3 out of 4. We have 2 out of 4 here. We have 2 out of 4 here. We have 3 out of 6, but we do not have 3 out of 4. So we cannot use the sine rule. So what we would tend to do is always look and see, can we use the sine rule? And then, having concluded that we can't use the sine rule, we decide we have to use the cosine rule. So use the cosine rule. Any questions about that, about why we can't use the sine rule? Okay, so now we have to use the cosine rule. So the first thing I'm going to do is I'm going to write it down. What do I have? I have that A is A, that's what I'm trying to find. I have that B is 11 C is 9, and angle A is 102 degrees. So I'm going to write that down because this is quite a complicated rule to sub into. It's quite a complicated formula. So I want to make sure I get everything in the right place. So what have I got? I've got A squared. That's what I'm looking for. This is what I'm trying to find. And that's always going to be in this space by itself on the left-hand side. So this is always what I'm looking for. Okay, that's what that is. Now, B is 11, so it's 11 squared. C is 9, so it's 9 squared. Minus 2 by B, that's always a 2. 2 by B, which is 11, by 9, which is C, by cos 102. Okay, so A squared equals B squared plus C squared minus 2BC cos A. A squared is what we're trying to find. B is 11, so it's 11 squared, plus 9 squared, minus 2 by 11 by 9 cos 102. This is a huge calculation at the end. So that's where we're likely to try to fall down, okay? Now, there aren't any brackets in this, but I'm going to put in brackets because it's really important. NB, please note, okay? You do all of this together before you subtract it. Okay, you can see there's a subtract here. You have to do all of this before you do the subtracting bit, and that's where people fall down. They don't do all of that together before they subtract it. They do this bit together, or they do these two together and then subtract it, and then they fall down. Okay, so A squared. 11 squared is 121. 9 squared is 81. Minus, I'm going to work this out on my calculator. So what have I got? I've got 2 by 11 by 9 by cos 102 equals. So minus, and then what's in the brackets, if you notice here, what's in the brackets is also minus. Minus 41.17. I'm rounding up that. I'm losing that 6 and rounding this 6 up to 7. Okay, so what do I have? I've got 121 plus 81 minus 41.7. So let's put that in the calculator. 121 plus 81 minus 41.7. And that gives me 243.7. Because if you remember, when we subtract a negative number, we're actually adding it on. Do you remember that from first year? When we add 121 plus 81 and we subtract negative 41.17, we're actually adding it on. So that's why we end up with 243.7. That's why we end up with such a big number. A squared is that, which means that A, as you know, is the square root of that. So I'm going to square root 243.7. And that is 15.6. So what I found is that the side A in my triangle that I was looking for is 15.6. So if I was to redraw my triangle where I can see it a bit better, what I have found, that was 11, that was 9, that was 102. What I found is that this side here is 15.6. Now, does that make sense? It does, because 102 is obviously the biggest angle in that triangle, and I found a side 15.6 that's bigger than either of the other two sides, which I'd expect it to be. If I'd found it to be that this side here was 7, I'd be a bit worried because it's opposite the biggest angle, so it should be the biggest number in the sides. Here, what can happen is people forget about the minus bit, and they end up with a negative number here. And as we know, with negative numbers, as far as you're concerned, you can't find the square root of those. There's an error there somewhere. Okay, let me just stop this recording.